The horizontal line test. Okay, so our objective for this video, we want to use the horizontal line test to identify graphs of functions that have an inverse. Okay, so what do we know already? Well, hopefully this reminds you of the vertical line test, and let's take a look at that. We know what a function is. A function is a relation in which each component of the domain, each input, each x value, corresponds to exactly one component of the range, or output, or y value. And here's what I was mentioning. The graph of a function will pass the vertical line test. So if it doesn't pass the vertical line test, it's not a function, okay? If it's not a function, it can't be a function that has an inverse because it's not a function. Okay, so inverses have ordered pairs with the coordinates reversed. However, in order for it to be an inverse function, these reversed order pairs must also meet the criteria up here of a function, which is each input corresponds to exactly one output. Okay, so the horizontal line test. In a nutshell, if any horizontal line intersects or crosses the graph of a function at more than one point, the graph is not the graph of a function that has an inverse. Okay? Again, the vertical line test tells you whether or not it's a function. The horizontal line test tells you whether or not it's a function that has an inverse function. Okay, let's take a look at some examples and we'll see if we can't make this a bit clearer. All right, use the horizontal line test to determine which of the following graphs represent functions that have an inverse. Now again, they're functions. So they've already passed, I'll write this down, they've already passed the vertical line test. If you look at all four of these, any vertical line only touches the graph in one place. So all four of these are functions. The question is, are they functions that have an inverse? Okay, well, we need to pass the horizontal line test. Well, here we go for letter A. As we draw lines, we notice that every horizontal line only crosses the graph in one place. So this is a function. Okay, again, we already specified they were functions. This function has an inverse function. Okay, it passes the vertical line test, so it's a function. It passes the horizontal line test, so it's a function that has an inverse function. Letter B, it passes the vertical line test, so it's a function. However, I can simply draw that line right there, and it intersects the graph in two places. So it does not pass the horizontal line test, so it doesn't have an inverse. So this one, no inverse function. Okay, letter C, again, it's a function. It passes the vertical line test. Is it a function that has an inverse? Well, I can draw this vertical line right there. I only need one. And notice that this horizontal line, notice this horizontal line crosses this graph in three places. That's certainly more than one. So this function does not have an inverse function. No inverse function. And finally, letter D, it's a function. It passes the vertical line test. Does it have an inverse? Does it pass the horizontal line test? And as you can see, the answer is yes. Any horizontal line only crosses the graph in one place. So this is a function that has an inverse function. Okay, fairly simple. If you've got vertical line test down, the horizontal line test isn't a whole lot more complicated. Let's make one more comment about this. Any function that passes the horizontal line test has a name. It's called a one-to-one function. In other words, it has an inverse. So a function passes the vertical, which I'll abbreviate VERT, the vertical line test. A one-to-one function, okay, a one-to-one function passes vertical and horizontal line tests. Okay, so if it's a function, it passes the vertical line test. If it also passes the horizontal line test, it's a one-to-one function, which means that it has an inverse.